This video is about how we can think of the Boyle's law from the context of the kinetic molecular theory. So first of all, the Boyle's law is like this. It states that whenever you increase the pressure of a gas, you will make the volume smaller. And whenever you decrease the pressure of a gas, its volume will actually increase. So, and again, because gases have four quantities, which is pressure, volume, number of particles, and temperature, when you're investigating P and V, you have to keep N and P constant. Okay? So to show this to you, let's go back to our animation that you have seen last time. So this is the animation. This is our container here, right? And we can pump in some particles of gas. And again, let me remind you that for this case, you have to keep the number of particles and temperature constant. So when we go back to this animation here, I will check this temperature. That means I will hold the temperature constant, so that temperature should not change. So what should change here is just the uh, volume and the pressure. But sir, how about the number of particles? Well, remember, number of particles is just the number of particles. So because we don't, because these particles here cannot escape. Remember, they can't escape. They cannot go out. And you can't add more. So it's understood here that the number of particles is also held constant. Okay. So let's do the experiment. Number one, what happens to the pressure? Remember, the pressure here is 29, around 29 atm. Obviously, it fluctuates. So let's just write it here. The pressure is around 29 atm according to our animation here. See, 29 atm, and our volume is this. Let's just call this one. Let's just call this 1 meter cube, okay, or whatever this is. Again, for simplicity, because there's no measure here, man. So let's just call this 1 meter cube, okay, just for simplicity's sake. And then what I'll do now is we will change this volume by half. Okay, so half meaning I will move this and make sure that it's only half of the volume. So let's do that. 1, 2, 3, go. So half is somewhere around here. So observe what happens to the pressure. 1, 2, 3, go. See that? Notice that now the pressure is relatively around 60 or 58 atm. Okay? So what does that tell us? So that tells us that when we make the volume half of its original, which is now 0.5 meter cube, the pressure becomes kind of double, so around 58 atm. See the relationship? When the pressure is high, right, the volume is low. So again, when the pressure is high, sorry, when the pressure is low, this one, remember this is 58, this is 29, so this is low. When the pressure is low, the volume is high, it's 1 meter cube. But when the pressure is high, 58, the volume is small or smaller, which is 0.5. So this is how you think about Boyle's law, which is the interplay between pressure and volume. So that's kind of an experimental fact. This is kind of an experimental fact that you can see here, right? Again, let me have half, twice the volume. Now the pressure goes to 29. If I decrease the volume to half, the 29 becomes double, around 58. Okay, so that's kind of experimental in nature. So what I really want to do now is kind of explain it from a conceptual perspective, why this is the case. Okay, why this is the case. Let us do that by, again, drawing it here. So if this is the volume, original volume, which is 1 meter cube, remember the volume after is half of that. So this is before, and this is after. Now, the way you conceptualize this one is think of one particle. Okay, let's not complicate stuff. Instead of multiple particles, let's think of one particle. So that particle has to kind of travel this, hit this wall, and then travel that, hit that wall, and again, for simplicity's sake, let's just have the particle traveling forward and backwards, and not really in random directions, for simplicity's sake. What that means is, even if it has a certain speed, when it hits here, right? When it hits here, it has to bounce back, wait for a few minutes before it hits here, and then it bounces back, wait for a few minutes before it hits this one, and so on and so forth, right? So it takes a longer length before, so it takes time before it hits wall A, and then it takes some time before it hits the other wall, takes some time before it hits the other wall. If you decrease the number of the volume, right, you make the walls closer essentially because you're decreasing the volume. What are you doing? Meaning, this particular particle, it hits the wall, and guess what? It will only take a shorter amount of time before it hits the other wall because the walls are, sorry for that, because the walls are kind of closer. So if the walls are closer, the particles can hit the walls more frequently. Let me reiterate. If the walls are farther, meaning bigger volume, the particles have to travel back and forth before it hits the wall. So it hits the wall less frequently. If the volume is shorter, if the walls are closer, meaning the volume is smaller, the distance that the particle has to travel to hit the wall is shorter, so therefore it can hit the wall frequently. Okay? So what that means is, if you have a bigger volume, it hits the wall, but not at a frequent manner. If you have a smaller volume, it hits the wall more frequently. So what does that mean? More frequent hitting means larger force. Remember? Larger force. And also, the area is smaller because you have made the volume smaller. So obviously, you will have a bigger pressure. Here, because your force is small, because you hit the wall less frequently, coupled by a bigger area, because the volume is bigger, then you will have a small pressure. Okay? So that's the idea why when you kind of make the volume from small to big, the pressure drops. But if you have the big volume and then you decrease it to a smaller volume, the pressure increases. So this is how we can think of conceptually about why in Boyle's law, when you increase the pressure, the volume drops. When you decrease the pressure, the volume increases. Okay?